Okay, please.
Good to go?
Yes.
All right, yeah, I can see it. All right, perfect. So good morning, everyone. Welcome to the research onboarding presentation. My name is Jake. For those of you who don't know me, I'm an academic at UWA in the medical physics department. And the purpose of this presentation today really is just to give those students that are new a sort of introduction to our research group, what the sort of expectations are when contributing to our research group, and for those of you who have been a part of our research group for a while, to explain the new processes going forward that we're going to be implementing when it comes to the storage of project data and also the storage of code that's developed as part of your postgraduate studies. So we'll jump straight in, and the first thing I'll get into is our weekly research meetings. So we have a weekly research meeting at 10 o'clock on Wednesdays. Obviously, those of you who are online know this, but for the new students who are watching this recording, you won't. The purpose of these meetings is basically just to discuss our research progress. And they have many different purposes, specifically for supervisors, but also for students as well. Firstly, they help students gain experience in presenting and communicating their work to their scientific peers. This is a very, very important skill to have, and it's one that is comprehensively developed during your postgraduate studies by attending these meetings. Secondly, it provides a forum for students and supervisors to be exposed to the work that others in our group are conducting. It doesn't really make much sense for us all to be sort of contained within our own little silos. It's important that we understand and know what the work is that's happening by other researchers in our group. Also, it provides a way for students to give and receive feedback and contribute ideas to the work of others. This is another really important skill that you should be developing throughout your postgraduate studies. It also gives an efficient way for supervisors to sort of stay up to date with the progress that students are making. Okay, so oftentimes internal supervisors, such as the people employed by UWA, myself and Pejman, but also external supervisors who are maybe part of the hospital staff, are extremely busy, and by attending these meetings, it gives a really easy way and efficient way for them to be updated on progress that their students are making. So in general, students are really strongly encouraged to participate fully in these meetings. There is a general expectation that there is one presentation by every student every 2 weeks. And I should say as well, this will form a component of your assessment. So specifically when you're undertaking the research units, you'll be expected to give 4 presentations per research unit that is being taken in the 12-week semester. So for example, if you're taking 2 research units, that means you'll be expected to give 8 presentations during the 12-week semester. So just a little bit about the research clusters that we have. Depending on your chosen project, you may be invited to contribute to one of our research clusters. You can see those clusters on the screen there. So we have the machine learning cluster. This is led by Nathaniel presently. We have the 3D printing cluster, which is sort of a space for 3D printing projects and people conducting those projects to discuss them and collaborate with each other on certain things. And also the Monte Carlo cluster as well, which doesn't have an official lead at this stage, although we do have our resident expert in Gavin, who's one of our PhD students. So the main purpose of these clusters is basically just to provide another forum for students that are undertaking similar projects to each other. So for example, those students who are all taking machine learning based cluster projects or AI based projects, you can have another way of meeting with each other and collaborating with each other and working through problems to help each other sort of get to the endpoint that you're actually after. And oftentimes these specific clusters will be meeting at certain time points during the week. So for example, our machine learning cluster meets pretty much after this meeting every Wednesday, starting at 11:30. So let's talk about the new process for storage of data and results that our group is going to be using going forward. So basically the problem thus far has been that critical data, code, and analysis results from our group have been stored in a relatively ad hoc fashion without any sort of standardization. And the common scenarios that we might have experienced would be that we would have multiple hard drives, for example, containing patient data and researcher results. This would lead to an inability to find results and or code that has been used or produced by previous students on particular projects. We've had a number of examples of this just in the last semester alone. It can also be very difficult as a result of this to quantify contributions made by students to the work of others. This is one thing that we really want to improve by enacting these processes. And also collaboration between students and staff is made difficult by the lack of standardized code storage. So these are factors overall really hamper the ability of our group to conduct, firstly, reproducible research. So we want our research to be able to be reproduced by future students and future researchers coming to look at the same projects, but also it makes it difficult to build on the work conducted by previous students and also to effectively collaborate with each other to improve those research outcomes. So essentially the aim of these new processes is to standardize how data results and code used by our group is stored. And the benefits that I foresee coming from this are that firstly, we have one location for the storage of critical research data. This is going to help us facilitate reproducibility of analysis, improved collaboration as well. This is one point that I would like to stress continuously throughout this presentation. We really want students and also staff members, when they have the time, of course, to be collaborating with each other, okay? This is going to help us improve our research outcomes. And another benefit is it's going to be very easy for us to track student contributions to code with that code being stored in GitHub. And I'll get into that a little bit later. So when it comes to the storage of project data, we're going to be using Microsoft Teams for this going forward. Now, supervisors are responsible for creating these Teams repositories. So students do not have to create them themselves. All you need to do is email myself and I can get this created for you very easily. Now, these repositories are going to be created at the level of data sets rather than the level of individual projects. Okay, so what this means is that you might have one data set related to prostate cancer, for example, and you might have multiple different students working on individual sub-projects related to that one data set. So in this instance, there's going to be one Teams repository for the data set, and then within that repository, you'll have different sub-projects where the students can store their results. Now, these particular Teams repositories allow up to 1 terabyte of storage per repository that's created. So there's plenty of storage space there. And we can also give access to external researchers as well. So people who aren't part of UWA, for example, can be given access to these. It is also possible to facilitate multiple levels of access for different team members. So for example, if a particular team member doesn't have ethics approval to access the full patient data set, we can give them access to just the anonymized pre-processed data set and have a separate raw data set of DICOM files on there as well. So here's an example of what this looks like. Hopefully most of you are familiar with Microsoft Teams. As students of UWA, you can download this for free. So you automatically have a Microsoft 365 subscription. And if you just jump onto your Teams tab on the left there, this is where your Teams repositories are going to appear. So you'll see that you have a number of different Teams repositories, and this is where your specific project one will appear as well. So in general, what do we want you to store in these Teams repositories? Well, there's a few things we want you to store there. First of all would be study protocols. So if you have any study protocols detailing pertinent information about your particular trial or your particular sub-project, these are the sorts of things we want to include in these repositories. Inclusion, exclusion criteria, very important to understanding what the data set is we're actually working with. So these sorts of things should be stored there as well. And this can also include things such as imaging protocols, so exactly how patients were imaged as part of this trial or data set or project. And also a log of ethics approvals can be kept here as well. Now, of course, another crucial thing that can be stored here is imaging data. So many projects in our group involve the use of patient images. Now, this can be used to store raw DICOM files, although this would depend on the particular size of the data set we're looking at, because we don't want to take up too much space. But ideally, what we would store here is pre-processed images into what we would call the nifty format that have been anonymized. So these particular types of data formats take up much less space, and of course, they're anonymized, so we're not uploading any sensitive patient information here either. Now, I should say this imaging data has to be accompanied by a README file, and I'll give an example of what this looks like in one of the future slides. But basically, this is just a file that explains all the necessary things about this data set so that someone coming to this repository And looking at this README file has enough information to understand everything that's going on there. And this includes things such as the file structure, what exactly the names of the files refer to. So there might be PET images, MRI images, CT images, etc. All of this needs to be made clear in the README file. We can store patient information here, although this does depend on ethics approval for certain projects. So this can include clinical information, treatment information, survival data, or any other data that might be of use for analysis regarding the project. The critical thing as well that we would like postgraduate students to store in these repositories is the results of their studies. So all important results achieved by you, the student, should be stored in this repository and appropriately named. Okay, so this enables future researchers to build on your work very easily if the work is intended to be built upon. And this does include trained AI models, phantom designs, etc. Okay, so if you've trained an artificial intelligence model, for example, we want this uploaded to this repository, or alternatively, you need to make it clear where exactly we can find this model and instructions on how we can use it going forward. And publications is another thing we can store in this repository. So if you've published any works as a result of this research, your master's thesis, your research proposals, your literature reviews, etc., all of this information can be stored in the repository as well. And important literature is the final thing. So if there are any important papers related to your study, you can store them here as well. So what don't we want you to store, excuse me, in this repository? Well, first of all, we don't want you to store code files here. So code files are not going to be stored in this Teams repository. We're going to have a separate GitHub repository where all student code is stored, and I'll get to that later on. We do not want you to store datasets without appropriate documentation. So as I mentioned, all these datasets need to have a README file accompanying them. And the reason for this is that if we're coming to this project, 3, 6 months down the track, potentially even longer, we need to be able to understand what is happening with this data set. We need to understand the file structure and what all of those files actually pertain to. This is very important. And also unnecessary data. So we don't want you to just flood this repository with data and results that aren't really directly related to your particular project. We want to minimize the clutter, essentially, in these repositories. And if you're unsure about any of this information, you can consult your supervisor or myself. Okay, so let's briefly go through the actual structure of what these are going to look like. So all of these research data repositories will have 2 channels as a minimum. It's going to be study data and sub-projects. And the aim is to keep the structure of these as consistent as possible across the various projects being undertaken within our group. But I do understand that this is going to be a little bit project dependent. So it may be the case that different projects require different channels, but as a minimum, these 2 channels should be present in all repositories. So the study data channel, pretty much as the name suggests, is basically just for storing the important data of the study. Okay, so this can include things such as ethics approvals, imaging data, patient information, and other details such as study protocols relating to that particular data set. Now, depending on your chosen project, you may be added to an existing research repository for a particular data set, or a new one will be created for you. So basically what this means is that in some instances, this particular section of the repository is already going to be pre-filled in for you. So the data will already be uploaded. You're simply being added to a data set that already exists, and your sub-project will then just be analyzing that data, right? But in other cases, we'll be creating the research repository from scratch, and so it'll be the responsibility of the student to upload the data into this repository. So as I mentioned, a README file is very important. So we need to understand what you're uploading, what it actually means, how we can interpret it, and how we can analyze it. So this is where the README file comes in to play. What it should contain is basically a detailed description of the file structure. So I've given a pretty comprehensive example of this on the right here. So you can see that in this particular example, I've uploaded a data set to my PSMA PET-CT imaging repository, and I've comprehensively detailed exactly what every single file within that structure is. Okay, so you can see I've said the scans for each patient are stored here. We have the patient ID at the top level, and then under that we have PET images. I've described exactly how those PET images have been pre-processed, so I've converted them into SUV. The CT images, original CT, not resampled, etc. So it's all exactly clear what every single file within this structure actually refers to. So it should have a detailed description of the file structure, any pre-processing that was performed on the data set or the files in order to get them into that format. And if applicable, you should note which part of the GitHub repository was used to process the data. Okay, so this is important as well. We want our results to be as reproducible as possible. Another thing that it should include is a list of all the locations outside of the research repository that you can actually find the data relating to this data set. Okay, so the reason that this is important, right, is that we may have multiple different hard drives where the raw data is actually located. And it's good to just have a list of locations where we can actually find that raw data in case there's any problems with this repository in the future. Okay, so just list all of the locations we can find the data outside of the repository. Now, one thing I wanted to mention as well is version controlling of data. So when it comes to imaging and other data sets, it can sometimes be beneficial to have multiple versions of the same data, right? And the reason for this, of course, is that we might want to facilitate multiple simultaneous sub-projects using the same data set, but perhaps we need to use different pre-processing methods in order to facilitate both of those sub-projects. Now, all changes made to a data set should be documented somewhere in the README file. As I said, all versions of a data set must have an associated README file. And then if you make any changes to this, you can update the version of your data set. Right? So let's say, for example, you're making a very minor change to the data set in the repository. You would increase the version number by 0.1. And a minor change would be something like you're just correcting a mistake in a patient file without modifying the file structure itself. Or you're adding a small number of patients with exactly the same file structure and exactly the same pre-processing methods implemented to this data set. So in that case, you would just document the changes in the README file and increase your version number by 0.1. However, if you're going to be making very major changes to a data set, then what we'd like to do instead is create a new version of that data. Okay, now in this case, we would keep the old version of the data and basically copy it into a new version with the changes that you want to implement in that new version, right? So let's say you want to make really large scale changes to the data set itself or the file structure in which that data set is stored. And one really good example of this is you want to implement different pre-processing methods that change the content of the files, right? So if you need to pre-process the data in a different way for your particular sub-project using this data, then we could store a different version of that data, and both sub-projects can be facilitated very easily using the different versions of the data. Okay, so that's the study data channel. Let's talk a bit about the sub-projects channel. So this is where the outcomes of all the sub-projects using the data set are going to be stored. Every student will have their own sub-project folder created for them, and it's going to be named basically after their research project. So here you can see I've created a file called Radiomics for Overall Survival Prediction. You can see that at the top there. This is a sub-project using the PSMA PET-CT data set that I've worked with during my PhD project, but this is going to be a separate project. So within this serves as basically your repository as a student to store those things that I mentioned in those previous slides. We're talking here about any study protocols that you've developed. We're talking about any results that you've achieved, critical results throughout your research project, publications, theses, final theses, research proposals, etc. All that information will be stored in these sub-project files. And it is your responsibility to make sure you do store those in these files so that we have an accurate sort of knowledge base of what you've done throughout your project, and then we can build on it if necessary, if you want to build on it or if a future student wants to build on that. And here's just a diagrammatic summary of pretty much everything I've been through up until this point. So we have our Microsoft Teams repository. We have these two channels as a minimum, study data and sub-projects. Within the study data section, you're storing the study protocols for that data set, any imaging data that you're using, which is appropriately version controlled and has a README file describing it, and patient information, if applicable. And then under your specific sub-project, you'll be storing your sub-study protocol. So if your sub-study protocol is different, from the actual study protocol for the full data set, you would store that within this folder. You then have your study results, including AI models and any phantoms that you've designed as part of this project, and your publications and important literature. Okay. So we'll move on to project code storage. So as I mentioned, we're going to be storing code not in the Microsoft Teams repositories, but we are instead going to be using GitHub to store the code that we've developed throughout our project. So why are we going to be using GitHub? Well, this allows us to version control code, which means we can track changes to it, revert to previous versions if necessary. It's also going to be able to enhance collaboration between researchers and students in our group. So we have our own GitHub organization, UWA Medical Physics Research Group. And within that group, using the GitHub processes, we're going to be able to collaborate much more effectively with each other, specifically when it comes to the development of code. One thing it's also going to do is enable transparency in contributions to research. Okay, so with GitHub, there's a clearly documented record of which people have contributed which components of code to what repositories. So we know exactly what students have contributed to exactly what projects. So it's very, very easy to inform, for example, authorship levels of manuscripts when we know exactly what contributions have been made by which students. It's also important for developing critical skills, such as good practice, coding habits, and also the use of GitHub as well. So these skills can be quite important for future employability in certain pathways. And as medical physics becomes more and more entwined with computer science, I think this is an important skill to have. And lastly, but not least, it does foster a smooth process of building upon work in future studies. So one of the problems that I mentioned at the beginning was that we have a situation or a scenario at this point in time where sometimes it's very difficult to find code that's been used by previous students or previous researchers and to build upon that in future studies because there's no standardized way of storing this stuff during the postgraduate research. So we've created our own GitHub organization, UWA Medical Physics Research Group, and this is going to basically house all of our developed code under the one umbrella. So what I would recommend is that students, new students, and also existing students as well, watch some tutorials for working with GitHub. The presentation today is not going to be long enough to give a full tutorial on GitHub, but there's plenty of resources out there that can help you when it comes to starting to make contributions to GitHub repositories. And I will be providing some resources in the future days and weeks as well that you can look at. Now, with this specific GitHub organization, so we have the overarching organization, and within that, we're going to have a number of different repositories that refer to code developed for different projects, different sub-projects, and different things, right? The overall structure is going to be structured something like this. So we're going to have two types of code repositories within our GitHub organization. The first type is going to be student repositories. So you'll have a repository created for you per student to store the code that you develop as part of your postgraduate studies. So you'll have write access to this repository, which means you can add code freely, subtract code freely. You can delete the repository, although I wouldn't recommend doing that if you would like to, because this is your own repository and this is where you're expected to store the code you develop during your studies. Now, this particular repository will have the same name as your sub-project in Teams, okay? So this is going to make it very, very easy to understand where both the code and also the results for all projects are stored, okay? So just make sure you don't change this name because you will have write access to this repository. But there will also be different kinds of repositories within this organization. So we're going to just be calling these general repositories. Now, these aren't necessarily going to be related to a specific student project, but they might be related to, for example, a larger project that many members of our team are working on, or it might be created to store useful code for specific types of analysis that aren't really project specific. So one of the examples I've given here is a medical image analysis, right? So it might be useful for us to have a code repository called medical image analysis. And within this repository, we store a whole bunch of functions and Python code, etc., that helps us to analyze medical images. And as a student, you will have access to this repository, but you won't have write access to this repository. So you'll just have to contribute to these repositories in a slightly different way. And I'll describe what that is in a moment. So as I said, with the student repositories, with the one that's created for you, you can freely add code, you have write access. It should contain two things as a minimum. So you should have a README file describing your project and the dataset version that you're working with. And you should also have a requirements file, okay? So this is quite important we need to understand the packages that were installed in your specific environment when you were developing the code for your postgraduate research, okay? And the reason we need to know this is because if we want to replicate it, we need to make sure we have those same packages installed in our own environment, okay? So this is one thing that you'll need to make sure you upload into this repository. But when it comes to contributing to general repositories or other students' repositories, you're not going to be able to contribute code to those directly, okay? Because you're not going to have write access. And that's just by virtue of the fact that we don't want you to be contributing or making changes to these repositories without, for example, the actual students whose repository it is giving permission for those changes to take place. But I should say it is very, very highly encouraged that you aim to contribute to these general repositories as well as other student repositories, okay? Because as I said, collaboration is extremely critical, and it's one thing that we can do to improve the research outcomes of our group. So what you'll need to do if you want to contribute to these repositories is really quite simple, although it can sound a little bit complicated. It's called a fork and pull request workflow in GitHub. Now, as I said, it sounds very complicated, but the basic gist of it is essentially that you have this repository that you want to contribute to. You create what's called a fork of that repository, where you basically just create a copy of it, which is then stored in your own GitHub account. Now, with that copy, you're free to make whatever changes you like, right? So you just made a copy of that repository. You can make whatever changes you like. That's quite simple, right? So if you want to contribute, the changes that you would make would be on that copied version of the repository. And then when you want to push it back to the upstream repository or the actual students or general repository that you want to contribute to, you submit what's called a pull request, okay? And this basically just says to the person who manages that repository, hey, I've made some changes here. Can you check them and see if you want them to be actually implemented in your real repository? Okay, so that's the basic gist of what happens there. And I will be circulating a PDF probably later this afternoon, which contains some of the details of this stuff. Now, there's many different ways to contribute to GitHub. Probably the easiest would just be using a nice GUI, right? A graphical user interface, which would mitigate the use of having to use command line prompts. So you've got GitHub Desktop, which provides a really nice GUI for you to be able to contribute code to GitHub. Also, what I personally use is Visual Studio Code. This is a really, really easy way to contribute to GitHub. It allows you to do pretty much everything that you can do in the command line prompts with a nice graphical user interface. It even has Jupyter Notebook compatibility as well, so you can write all your Python code or whatever code you're writing in your preferred thing, and then upload it straight to GitHub or commit those changes to GitHub. But of course, you can use pretty much whatever editor or language you want. You can write them in Jupyter Notebooks, MATLAB files. You can just write basic Python files, etc. And then you can save those files and commit those to the repository using command line prompts. Although that's slightly more difficult, but not particularly difficult, and it's very easy to learn. So just the final thing I'll finish off with here is that as a postgraduate student studying with us, it is your responsibility to ensure that the code you've developed during your studies is stored in GitHub, okay? And you should be aiming to make consistent, regular contributions to the repository and not simply just dumping your code at the end of your project onto GitHub after you've completed it, okay? So we really want to have that sort of history of how you've made changes to your code, how you've contributed to other students' code, etc. Okay. Now, of course, the frequency of expected contributions is very, very highly project dependent. Okay. So we have a lot of people in our group who are undertaking very practical projects, for example, creation of 3D printed phantoms, etc. And the frequency of contributions for these sorts of projects is not going to be as high, if any at all, depending on the project. Okay. But for projects that are very code heavy, for example, pretty much any project that involves the analysis of medical images, you should be aiming to contribute pretty consistently and regularly to your repository. And the code should conform to certain standards as well. So it should be clearly documented, readable. You don't want to be uploading something that looks like a dog's breakfast to the GitHub repository, which makes it impossible for a future researcher to understand. And finally, you should also include the version of the data set in your associated team's repository that the code is designed to analyze. And pretty much the ultimate goal of all this is to enable another researcher coming to your repository who, hasn't developed the code, maybe understands a little bit about the data set, but they can understand exactly how to run that code, on which data set it should be run, and ultimately, if they would like to build upon that code as well. So I'll leave it there. That's pretty much all I have. If you have any questions in regards to this, I'm happy to take them now, although if you're not comfortable asking questions now, please feel free to email me. I've got the email address on the screen there. And thanks everyone for listening.
Thanks, Jake. Should I stop recording, Jake?
Yeah, you can stop. Apologies, I went a bit longer than anticipated.